Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
That's adorable. Hi, everyone. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe, and a friend to my co-host.
It's true. And I'm Corinne Caputo, a friend to the universe, friend to Dr. Moiya McTier, and a friend to the listeners here.
Aww.
And I took you to one of my favorite spots, which is the boba tea place.
Love this. What's your go-to order?
Some places will do a cold brew with boba, which I like.
Ooh, okay.
But
that was not an ew. I
figured. Yeah.
Okay. Yeah.
But I like kind of just a black tea, milky thing with boba. Mm-hmm. There's also one by my apartment that does like lychee jelly instead of boba.
Ooh.
Sometimes I want that, but it's pretty sweet, and I kind of go bitter usually.
Interesting. It is very sweet. I like it sometimes. I have a sweet tooth. I will either go with like a classic taro milk tea, or if I'm feeling something fruity, and also because I have a little delicate tummy, I will get something like a passion fruit flavor.
Yeah. There's also, I love a Thai iced tea with boba.
Yes.
That's probably my fave. But I can't always do condensed milk.
Yeah. It's heavy.
Yeah.
And that's okay. But there are so many good options. Thank you for bringing me to your boba spot.
You got it. Also, boba tea straws are my favorite. All straws should be huge.
I agree. I got a blender once to make smoothies, and it came with a big boba-sized straw, and I was like, yes.
Oh my God.
This is what I need.
Well, that's such a good get. Was it like a reusable straw?
Yeah.
Oh, good. Oh, so we're drinking smoothies. Duh. I'm like, that's such a weird thing they threw in your blender.
Yeah, because smoothies are thick. Yeah,
yes,
and they have chunks in them. Mm-hmm.
Agree.
Mm-hmm. But boba tea is also so appropriate because the little bubbles, they're so small. Mm-hmm. And we are talking about the smallest planet in our solar system. Was that intentional, Corinne? Is that why you brought me here?
Oh, yeah, I knew that. And that's why we came here.
Yes, claim it. We're talking about Mercury. It's the smallest planet in the solar system. It's the first rock from the sun, and it is caught up in history and mythology, and we've sent a couple of missions to it. So we're going to do a deep dive into the planet Mercury today.
Yes.
What are your Mercury impressions before we get started, and what do you want to know by the end of this episode?
The habitability of Mercury, which feels like 0 because it's so close to the sun. And I kind of want to prove or disprove that guess that I have.
Oh, great. Then at the end, after I tell you some features of Mercury, you can let me know if you think it would be habitable and if you think your instinct is right.
Love it.
Great. Where does it fall in the list? Is it top?
Ooh, in planets?
Top 4?
I've definitely ranked the planets before, so today's ranking might be different.
Yeah, it's fluid. That's fine.
I feel like it goes Earth, Mars. I'm afraid of how large Jupiter and Saturn are. I think Mercury and Venus are like the other top 2 for me.
Wow, that's
But that's just today.
Yeah.
Ask me again next episode.
Come back next time to figure out. I think it's probably in the bottom half for me.
Oh, okay. Well.
Yeah. But that's not because of anything it has done. There are just some fantastic planets in our solar system. But let's get talking about it. As with all of the planet episodes, we're going to start with the history and how people have observed and thought about Mercury in the past. This is one of the OG wandering stars, one of the 7 moving points of light in the sky that the ancient Mesopotamians talked about. So the Assyrians, who were like one group of the Mesopotamians, they wrote about Mercury in their tablets that describe their knowledge of the sky. Collectively, they're called the Mul-Apin tablets, or Mul-Apin tablets. And they describe Mercury as the jumping planet, which is so cute, like a little jumping spider, because it just moves around so fast, and it seems to jump from like one side of the sun to the other very quickly.
That's cute.
So cute. The Babylonians, who gave us our 7-day week, they called Mercury Nabu, or they said that Nabu lived there. Nabu was their god of wisdom and writing, and he was a patron of scribes, and he worked for the head god Marduk, and he was associated with the day Wednesday, and that association got carried on. So the Vedic mythology is like a kind of precursor to Hindu mythology. They had a god named Buddha who was associated with Wednesday. The Norse Odin is associated with Wednesday. We have Wednesday because of Woden, which was another one of Odin's names. And they both were gods who oversaw Mercury and were associated with Wednesdays. So we can still see this this ancient folklore reflected in our days of the week in many languages, in Germanic and Romance languages. So I love that. And a lot of those associations come from characteristics that are easily visible of the planet. It's very fast as it moves across the sky. It's small and it's bright because it's so close to the sun, so it's reflecting a lot of the sun's light. It's easy to associate with messenger gods because it's so fast.
Yeah.
And so the Greeks associated it with Hermes, but they also associated it with Apollo, mostly because of the proximity to the sun. And it was like, I can't remember which way it was, but it was something like in the morning it was Hermes and in the evening it was Apollo, because these planets can appear in the morning right before sunrise, or in the evening right after sunset. And especially Venus does this. It can be called the morning star or the evening star, depending on when you see it. And they would often think that it was a different star.
Okay. I also am a different person in the morning and the evening. So
yeah.
I relate to this.
That's so true. I love when you see the truth of this, Corinne. So that's ancient history before telescopes. They were first observed through telescopes in 1610 by Galileo, although there's some contest there. Another scientist around the same time, Thomas Harriot, also claims to have seen Mercury, and claims to have seen it in 1609, so earlier than Galileo did. So it's unclear, and I've been thinking about this a lot for my book.
Yeah.
So this time period has been actively on my mind. There were other scientists who were observing Mercury very soon after the invention of the telescope. Simon Marius was documenting the phases of Mercury in 1612 to confirm that it orbited the sun, which back then was not necessarily heretical. There were a lot of people who believed that Mercury and Venus went around the sun, but the sun went around Earth. So by proving that Mercury went around the sun, they were not doing anything that went against the church too
much.
Too directly.
Yeah.
Everything in moderation is fine. Around the same time, Galileo was claiming that all of the planets got their light from the sun and didn't emit any light themselves, which meant they all must orbit it, but he was being a little hush-hush about some of his findings. November 7th of 1631, the first predicted transit of Mercury across the sun happened. Johannes Kepler, the namesake of my fave Kepler spacecraft, predicted that this transit of Mercury would happen. He was studying and tracking the motion of planets so that he could mathematically understand their orbits, which is how he gave us Kepler's laws, and one of the planets he was tracking was Mercury. But he did responsibly, like a good scientist, admit that there was some uncertainty in his prediction. So he was like, people, please be out looking for this transit for a few days before and after, and he didn't get to see it. He died almost a year before the transit happened, but astronomers did observe it on the exact day that he calculated, but a few hours off. They observed it around 9 a.m. Europe time. I don't remember where he was. Probably Italy. I'm sorry. And it made them realize when they saw that transit exactly how small Mercury is, because it looks like the tiniest bit of darkness going across the sun. In the 1850s, a French scientist, Urbain Jean-Joseph Leverrier, turned his attention from finding Uranus to solving Mercury's wobble problem. There was apparently a discrepancy in Mercury's location when it reached the closest point to the sun. That point is called perihelion. And so there was this discrepancy in the orbit. It didn't match predictions. And before, when they saw planets in the outer solar system that were moving and behaving in strange ways, that ended up being explained by an even further planet in the solar system. So they tried to do the same here. They tried to say that there was a planet closer to the sun than Mercury was, and that was tugging on its orbit a little bit. And so they named that planet Vulcan, and they spent decades looking for it. In 1859, an amateur astronomer, Edmond Lascarbot, saw a sunspot. Leverrier assumed that sunspot was proof of a small planet between Mercury and the sun.
I can see why you might think that.
Yeah, but we'd known about sunspots. Galileo was studying sunspots 250 years before this. So that's just jumping to conclusions. They thought that this planet existed until 1915. There were people who were still willing to, I don't know if they were willing to die on this hill, but like there were still people who were very supportive of the Vulcan planet idea until 1915.
That is so recent.
So recent. It's a little bit more than a century.
Yeah.
What happened in 1915 to disprove this ludicrous idea of a planet inside Mercury's orbit was Einstein proposing his theory of general relativity. And that November, he ran a calculation with his new theory of general relativity. And the calculation matched observations of Mercury's orbit change. So the point in Mercury's orbit where it's closest to the sun isn't always in the exact same place. It scoots ahead in the orbit over time, meaning it happens later over time. And all of the planets do this. All of the planets in our solar system do this. It's a consequence of gravity. And this is why it was Einstein who was predicting this, because general relativity has to do with the true nature of gravity. And so he calculated how much of an effect this should have for all of the planets. And it's basically negligible for all of the planets except for Mercury, which is closest to the sun, so experiences it more intensely. And his calculations matched observations, so people were like, oh, okay, there's probably not another planet in there.
Okay. We'll admit it.
And so we've known about Mercury for literally thousands of years. We've been studying it through telescopes for 4 centuries. We have learned a lot about this little rocky planet so close to the sun. It has a radius of about 1,500 miles, or 2,400 kilometers for our international listeners. That means Mercury is a little bit more than 1/3 the width of the Earth. So if Earth were the size of a nickel, then Mercury would be as big as a what, Corinne? I found this comparison on, I think, a NASA website, and I want to hear your comparison. So what's about 1/3 the size of a nickel? And then I'll tell you what they used.
1/3 the size of a nickel. I feel like a seed for an apple, maybe?
Oh, that's not bad. That's nice. That's nice. They used blueberry.
Oh, blueberries are huge now.
Blueberries are huge now. Exactly.
Maybe they mean like a wild blueberry in Maine?
Yeah, those are tiny. But I was thinking like a chocolate chip.
Oh, yeah.
But blueberries are too big now. Yeah.
I don't know. Maybe I haven't seen a nickel in a long time, but nickels are like...
I actually do have a nickel literally right in front of me, and blueberries are almost this big now. Like the blueberries you get in the store.
They're huge. People are always posting them online, like, look at this big blueberry I got. And I'm like, guys, you're never taking the photo far enough away for me to have context for how big this blueberry is.
You need something for
sidebar. Yeah, I'm like, please... understand that I don't know what I'm looking at.
So, yes, if Earth were the size of a nickel, Mercury would be about the size of like an apple seed. I think that's a much better comparison than a blueberry.
Okay.
That means Mercury is just barely bigger than Earth's moon. It is just about 5% the mass of Earth. And so if you do the math out to figure out what its gravity should be, gravity on Mercury is almost 40% as strong as gravity on Earth. I think it's like 39 point something percent.
Okay.
So it's small. It's so small.
So I could jump really high.
Yeah, you could. You could easily dunk on Mercury. No problem. You wouldn't even break a sweat.
I would be the star.
Yes. We just make sure that no basketball players go with you.
Exactly.
The planet rotates on its axis every 59 days and basically has no tilt, so it doesn't really have seasons like we do. We have a tilt of 23 degrees. Its tilt is less than 2 degrees. It's basically negligible. It has an average distance from the sun of 36 million miles, or 58 million kilometers. That's 0.4 astronomical units, so 40% the distance from the Earth to the sun. Because Mercury is that close to the sun looks a lot bigger and brighter. It looks about 11 times brighter.
Whoa, that's so bright.
It's so bright. I imagine that if any life were to form on Mercury, it would have to have very different sight system than we do.
Yeah.
It is one of the most I think it's the It has the most eccentric planet orbit in the solar system after Pluto has been disqualified because it has an eccentricity of 0.206, and most of the other planets are like 0.1, 0.0 something.
Wow.
That means that it's 70 million kilometers away from the sun at its furthest point, and it's 46 million kilometers at its closest point. And it orbits the sun every 88 days.
Quick.
Yeah, it orbits the sun every 88 days, but it spins every 59 days. And those numbers are very close to each other. And so daytime is a weird concept on Mercury. The morning sun appears to rise briefly, and then it sets, and then it rises again. And this all looks different from different parts of the planet's surface. Depending on your latitude. And because the rotation period is a significant fraction of the orbital period, one solar day, so one full day-night-day cycle, is 176 Earth days. So it's actually several years. One Mercury day is several Mercury years, which is wild.
That's so hard for me, an earthly being, to imagine.
Yes, this is what I'm saying. Space doesn't owe you any default parameters.
No.
A year does not have to be longer than a day.
No, not at all.
It is the second densest planet in the solar system after Earth. We are number one. It has a large metallic core that goes out to about 85% of the planet's radius, so most of the planet is this metallic core. And it might be partly molten, but we're not sure, and that might change over time. It probably does. And then outside of that core, it has a shell about 250 miles thick, which is thicker than ours. And the surface of the planet is covered in impact craters from comets and meteoroids.
Dirty.
Temperatures are wild. Temperatures are wild on this planet.
It's got to be so hot, right?
It's very hot, but it also gets very cold because it doesn't have an atmosphere. So during the day, when a part of the planet is facing the sun, it can reach 800 degrees Fahrenheit. And then when you're facing away from the sun, because there's no atmosphere to transport heat around the planet, it gets to minus 290 degrees Fahrenheit.
Oh, no. Bad.
Very cold. It's cold enough that at the poles where sunlight might never have reached down to the bottoms of some craters, there is water ice. There's permanent ice caps at the poles because they never see sunlight. The planet has no moons. It has no rings. It has, again, no atmosphere, just a thin... It's called technically an exosphere made of atoms that just got kicked off the planet's surface by the charged particles in the solar wind, which is really sad. And most of them are oxygen, sodium, hydrogen, helium, and potassium. And so the composition of the exosphere tells us a lot about the composition of dirt, essentially, on the surface. It does have a magnetic field, but it's pretty weak. It's about 1% the strength of Earth's. And the axis of the magnetic field is offset from Mercury's rotation axis, which is common. Ours is too, but theirs is really offset. I think ours is something like 15 degrees, and theirs is much, much more than that. And so it might not have a strong magnetic field itself, but it is very close to the sun, which has a very strong magnetic field. And so sometimes Mercury gets what's called magnetic tornadoes. The two magnetic fields will just interact with each other, and you'll get a funnel going from the sun to the surface of Mercury of just hot plasma.
Oh my gosh.
That hits the surface. Yeah, sounds awful. It's not volcanically active, but it used to be, probably stopped about 3.5 billion years ago, and it is, for all intents and purposes, a chunk of rock.
Yeah.
Very, very close to the sun.
Wow, that's a fun way to put it.
You're just a chunk of rock, very, very close to the sun.
I think I didn't realize it was so lonely. Like it had no atmosphere, moons, rings, friends.
Very bare. A good Spartan planet.
Yeah, exactly.
Mm-hmm. I think the Spartans would have liked it a lot had they known all of this information.
Yeah, I can see that. Hi, it's me, Corinne. As Moiya gets us some more boba, I'm going to say a huge thank you to our patrons who are supporting the show every single month. So thank you to our Sun-like stars, Sharon Llewellyn, Lissa, Scott Reynolds, Ian O'Leary, Augustin, and Tom T. And of course, you can support us, hear your name on the show, make it to our patron star chart, all by supporting us on Patreon for just about $1 per episode. And if you sign up for an annual membership, you get a 13% discount. Pretty good. Find the star chart, Patreon info, and more at our website, palebluepod.com, or by going right to patreon.com/palebluepod. And if you can't support us financially, that's totally cool. We love you very much. And you can always support us by reviewing the show on whatever app you use, or share the show with your friends. And before we get back to Pale Blue Pod, I want to recommend another pod in the Multitude family. Spirits is a history and comedy podcast focused on everything folklore and mythology and the occult, all told through the lens of feminism, queerness, and modern adulthood. Every week, mythology buff Julia and her childhood best friend Amanda get together to learn about a different story from mythology and folklore over drinks. That's everything from the mythological origins of major franchises like Lord of the Rings and Wonder Woman, to modern urban legends, to a roundup of werewolf stories from around the world. And there are episodes that Moiya and I guest on, and it's so fun. So you can start by listening to those episodes or any of the 300 plus episodes they've released over the last 6 years. So if you're here for an analysis of mental health and mythology or creepy modern ghost stories, there's something for you, I promise. Dive in at spiritspodcast.com or search for Spirits on wherever you download your podcasts. Okay, bye.
Would you like to know how we've been studying Mercury for the last few decades?
Yeah, let's do it.
We did for a really long time think Mercury was tidally locked. Do you remember what tidally locked means, or synchronous rotation?
It means that like only one half of it is facing away. Like it's never...
For something to be tidally locked, its day has to be the same amount of time as its year. And so we now know that Mercury isn't tidally locked, but before we had measured its rotation speed, we thought it was. And that was because when Mercury's face was visible to us, and because it's so close to the sun, it was really only visible to us when it was very, very far away, or like as far away from the sun as it could be. The same features were always showing. So we assumed that it was tidally locked, like the moon, but it just has that very slow rotation speed. On April 6th, 1965, radio astronomers Gordon Pettengill, Pettengill is a great name, and Rolf Dice used Arecibo, the Arecibo telescope, RIP, to bounce radio signals off of Mercury's surface, and they were able to measure its rotation speed that way and figure out that it's not tidally locked.
Cool.
Yeah. And we've sent a couple spacecraft to it. Mariner 10 did a flyby, and we might do a whole episode on Mariner and the other missions, but let's just talk a little bit about it now. Mariner launched in November of 1973. It passed Venus in February of 1974, and I checked to see if it passed around Valentine's Day, because I think that would have been perfect marketing.
Yeah.
And it turns out it was like 10 days before. Just like,
Aww.
Yeah. It flew by Mercury a few times, once on March 29th, and then again on September 21st, and then again on March 16th, 1975. It was the first mission to use a gravity assist. So a gravity assist is when you fly very close to a moon or a planet and you use its gravity to slingshot you towards something else. It's a more efficient way of traveling because you don't have to use as much fuel. So it used a gravity assist off of Venus, and it got about 200 miles from Mercury's surface. Mariner 10 was equipped with cameras, some that were specifically designed to see charged particles, so they could study the solar wind and interactions between the solar wind and Mercury. It also had an infrared radiometer, which measures electric power, because they wanted to measure any sort of electrical signals, electromagnetic signals. It had UV spectrometers, so ultraviolet spectrographs that could split ultraviolet light up into its parts, and that's so that they could study the UV part of the sun's spectrum and also see like what Mercury is doing down there. Mariner 10 imaged 45% of the planet's surface, mostly the darker side, because the bright side is too hot.
Yeah, that makes sense.
It had a magnetometer to measure magnetic field strength, and it had something called a plasma analyzer.
Ooh, that sounds funny.
Yeah. This is like a little lab thing that could analyze plasma from the sun during one of those magnetic tornadoes.
That does seem like a tool I would invent for myself as a kid during, like, pretend play.
Yes. Look at my fancy plasma analyzer.
It's actually thrilling to know it's real. So.
Yes, that is a direct quote from the NASA site. They call it a plasma analyzer on their site, so I figured I could repeat.
They should do little printables for kids of, like, fold this into, my brother and I were always making, like, little boxes we could wear on our hands and, like, pretend we were, like, robots and stuff.
They should.
NASA, think about it.
That would be a great, like, semi-DIY costume where it's, like, big sheets and you fold it into the right shape. Yeah.
Mm-hmm. Okay, another idea we're doing.
Yeah. God, we have so many ideas.
Too busy for this.
Okay, that was Mariner 10. Then we sent Messenger, which I didn't realize was an acronym, but it's an acronym. It stands for Mercury, Surface, Space, Environment, Geochemistry, and Ranging. Messenger.
We're missing...
Okay. Mercury has M-E, Geo is G-E, Environment is E-N. Yeah.
Okay. G-E-R.
Yeah.
Okay.
Uh-huh.
Yeah.
So it's not the worst astronomy acronym I've ever seen.
One of the better ones, even. Yeah.
But it was unnecessary.
Totally.
Especially since we were sending it to Mercury, named after the messenger god. Like, we didn't need...
That's a good point.
It's a little on the nose.
But isn't it more fun when it works on every level?
Yes, I suppose so. But, like, they had to try. It launched in August of 2004, and it entered Mercury's orbit in March of 2011. So it took 7 years to get there.
Wow, that was a long trip.
A long trip, yes. And I'm not totally sure why. I don't think it ran into issues. I think it was just on a fuel-efficient path.
Hey, I think a casual road trip is the way to go.
Yeah. So it got there in March of 2011. It orbited Mercury for 4 years and then crashed into the surface of the planet at the end of the mission in April of 2015.
Aww.
It found some pretty cool stuff. So Messenger was able to image the entire planet. It took more than 200,000 pictures. The goal was just 1,000 pictures.
I love this habit of setting the goal to something super manageable and then exceeding every time.
Me too. And every single NASA mission seems to do this.
That's what we should do.
Yes, set realistic goals.
Yes.
So it imaged the entire planet. It found high concentrations of magnesium and calcium on the night side of the planet, like higher than on the day side of the planet, I guess. Mm-hmm. It found that significant offset between the magnetic field orientation and the rotational axis. And it found evidence for water at the poles, which is something we've been looking for in many other parts of our solar system for a long time. And then it ended in 2015. There are now a couple instruments that are on their way to Mercury as we speak, and there are some future missions planned. So one that is on its way to Mercury right now is called Bepi Colombo.
What?
Yeah.
Bepi Colombo.
Bepi Colombo. It's a collaboration between JAXA, which is the Japanese space agency, and the European Space Agency. It launched in 2018. It should reach Mercury in 2025. It's going to orbit Mercury, and it's actually two different spacecrafts that are being launched together. The two different instruments are Mercury's planetary orbiter, and then there's Mercury's magnetospheric orbiter. So they'll be studying slightly different things. One of them is going to have more of an emphasis on studying Mercury's magnetic field. Mm-hmm. Both are expected to operate for 1 year, but like you said, there's this trend of them exceeding expectations.
I bet 2 to 7.
Mm-hmm. Okay. Oh, we should take bets.
Ooh. Suddenly it's a gambling rink.
You're right. Let's not open up that can of worms. It was named after Professor Giuseppe, or Bepi Colombo, who lived from 1920 to 1984. He worked at the University of Padua in Italy and was a mathematician and engineer. So that mission hopefully will tell us a lot of cool stuff about Mercury.
Yeah.
The Russian Space Agency has proposed a Mercury lander mission called Mercury P that is expected to launch in 2031, but I am skeptical.
We got time, and I don't know.
But Do you think Russia's going to be launching sending something to Mercury?
That depends if they're listening to this podcast or not. My answer depends on if they're listening.
That's so fair. Okay, then let's leave it at that. And that is so far what they have proposed.
Well, good luck.
Yeah, good luck. I think that the big open questions for Mercury these days are more about its magnetic interactions with the sun, probably more about its composition and its heat transfer mechanisms, definitely studying more of the water at the poles. Maybe they can try and get a sample one day of that frozen ice that never sees sunlight. But that is what we know about Mercury so far.
I love Mercury.
Yeah.
Well, okay. So when you look up pictures of Mercury, or when I think of Mercury, I think of there's one colorized picture that I assume it's colorized, that it's purple and blue and yellow. Mm-hmm. And I don't know why, because every other picture of it just looks like the moon.
Yeah.
With less enormous craters maybe. But the colorful one is very mesmerizing to me.
Yeah, that's color corrected, but it's observing in a different wavelength. That's probably in the UV wavelength.
Yeah.
And so we often color code UV to look like blue and light purple and yellow and stuff like that.
Yeah. It looks like the epitome of remember when galaxy nails were the big trend?
Yes.
It looks like that.
Yeah. We're trying. One of the ways that we can study interactions between Mercury and the sun is by studying both of them in the UV, because the sun gives off a lot of ultraviolet rays, and Mercury is going to look very different in the ultraviolet because it's reflecting a lot of different types of light. But how do you feel about your intuition for Mercury's habitability after hearing about it?
There's nothing going on there.
Yeah.
Don't move there. There's nothing happening.
There's just water at the poles and it's frozen. There's no atmosphere. You can't breathe.
Yeah, I'm curious about the frozen water, but I'm too hot or too cold, too much sun. I'm not good in the sun, so this is just not the place for me.
Complicated day-night cycles.
I'm already dealing with it now.
So even if people did live there, they'd be so confused.
Yes. Okay. Not the best planet, but I love how fast it is. I love it being zipping around.
Yeah. Yeah, and that's why it had that association for so long. So it really is one of its defining characteristics. Mm-hmm. Okay, we have a game. We have a little funtivity for you, Corinne. Mercury doesn't have any moons, so we can't play our normal Match the Moon game, but Mercury does have a lot of craters, and I was really happy to see that there is a naming convention for these craters.
Ooh, that's exciting.
I know, right? I love that the IAU has just decided that these are the rules. We got to stick to them.
We should be thoughtful. Yep.
There are more than 400 craters on Mercury and most of them have names. The naming convention is that they are named after artists, musicians, painters, and authors who have made outstanding or fundamental contributions to their field and have been recognized as historically significant figures for more than 50 years and have been dead for more than 3 years.
So you're saying we have a shot?
Many, many years from now.
May it be many, many years from now.
3 years after we're dead, yeah. But we have a shot.
All right, I'm ready.
Okay. We're going to do 5 of these. 1, 2, 3, 4, 5. I will tell you about an artist or a musician or painter or whatever, and you tell me which crater you think it is. They are Rembrandt, Goethe, Mistral, Kipling, and Bronte.
Okay.
Starting with number 1. Born in 1865, this writer was born in India, technically. They wrote The Jungle Book in 1895 and the poem If in 1910. They won the Nobel Prize for Literature in 1907 at 41 years old, the youngest recipient then. They declined the British Poet Laureateship and knighthood, and their ashes are interred at the Poets' Corner at Westminster Abbey.
Okay, is it Rudyard Kipling?
Yeah,
is that the first name?
Kipling. Yeah,
Rudyard. Yes, I knew that from the Jungle Book.
Mm-hmm. I took a class in high school where the teacher made us memorize a bunch of different poems and monologues and stuff to perform in front of the class. And one of the things we had to memorize was the poem If.
Really? Was
Yeah.
it hard? I'm not good at memorizing.
I am pretty good at memorizing. So, especially back then, I was in marching band. Like, my memory skills were sharp.
Yeah,
so I found it pretty easy, but people definitely struggled with it for sure.
Yeah, I get it.
Mm-hmm. Great job.
Fun. Okay. I feel like this quiz is, like, more up my, like, knowledge alley than past one. So let's see how I do.
I have a lot of faith in you and confidence. Oh, wait. I also have information about the crater. So the crater Kipling was named in 2010. It's 165 kilometers across, and scientists think it was likely created by multiple eruptions in what they called a compound vent situation. Ooh. And it's one of the bigger craters on Mercury.
Get it.
Woo. Okay, number 2. Born in 1749, this German writer penned everything from poems to plays to novels, even some science, namely botany and anatomy, and they wrote Faust, the story about the doctor who makes a deal with the devil to know everything.
Me. I would do that.
Yes, it is you. It's the Caputo crater. Yeah. That would be such a good name for a crater.
There's a good ring to it.
Yeah.
Okay, we'll get this done. Okay, so we have who's left?
Rembrandt, Goethe, Mistral, and Bronte.
I think I'm going to say it wrong. Goethe.
Yeah, it is. It's Johann Wolfgang von Goethe, who I learned about in my German class. My teacher really liked to talk about him. Same teacher who taught that class where we had to memorize the poems.
Okay. What a good class.
His name was Herr Schrock. He was the German teacher and the 12th grade language arts teacher, and his name meant Mr. Fear.
Oh my God, spooky. Don't like that.
Yeah, he was the most intense teacher at the school, for sure.
The only person on this list I'm not sure about is Mistral, so we'll see.
I had not heard of them either. But you're doing great so far. The Goethe crater is 300 kilometers across. It was seen by Mariner, but the picture was too fuzzy, and it was named in 1979. So it was studied in more depth with the Messenger mission.
Mm-hmm.
Yes.
Cool.
Number 3. I think you'll get this. A family of 3 from the 1800s. These siblings are known poets and novelists. Their works include Jane Eyre, Wuthering Heights, and The Tenant of Wildfell Hall.
It's Bronte.
Yes.
Bronte.
For the sisters, Charlotte, Emily, and Anne. Are you a fan of any of their books?
I'm not a fan. I think that when I was a kid, it was hard for me to get into old books. Like, there was just something broken in my brain about, I couldn't realize that people have been experiencing similar things for eternities. So now I am on board. But when I was a kid, I was like, no one knows what I'm going through, and I can't possibly read something ancient to me, a teenager.
Right, of course. Well, I mean, hundreds of years when you're a teen, like, that's pretty ancient.
Yeah. I think I also didn't always have a great teacher. When I did have a great teacher, I was fully on board with, like, reading anything they recommended. But yeah, teachers are really impactful.
Yeah,
Shocking
they can
news.
be. For better or worse. You know how Facebook shows you your memories?
Oh my God, I just got a memory today.
Ooh.
Yes, I know exactly this.
Nice.
The memory is just like of my old roommate.
Because I'm familiar with the concept of memories, Moiya. I saw very recently one where I had apparently been assigned Wuthering Heights to read in some class. And the post was like, I fucking hate Wuthering Heights. I hate AP Lit, and I don't want to read this. And then a couple days later, I saw a memory of a post that was like, Wuthering Heights actually isn't that bad.
That's so funny. The evolution.
Yes. I posted on Facebook a lot in like 9th and 11th grades.
Yes, same. Yeah. It's bad.
I don't think I read Jane Eyre though, or The Tenant. I just read Wuthering Heights. This crater was named in 1976 after the sisters, and why'd they all have to get one?
I know.
It just seems unfair. They had their
like
own
co-writers. Yeah, they all did their own thing.
Yeah. There actually is a shortage of women on this list of named craters, which is disappointing. There are other naming conventions in other parts of the solar system that aren't mythological. You know, there are some that are named after humans, and others have more women on the list. And it seems weird but not surprising to me that this list of like professional artists would have so few women, because it's so subjective. And it shows me that the IAU is like undercounting the artistic contributions of women.
Hey, it's true. I remember getting in a fight with someone on Facebook, RIP, again, this is the theme of the game, where they were upset about how many women were in like the new Star Wars. And I was like, are you telling me that it makes more sense for there to be aliens than women?
Yeah.
This is a fictional, we've made this up.
Ugh.
This whole thing is made up. Anyway, not a direct correlation, but I'm like, some people are weird about us in art.
Okay, number 4. Born in 1606, this Dutch painter worked in a wide range of styles, known for self-portraits, and there's some dark biblical stuff if you look through their portfolio.
Okay, spooky.
Yeah.
I think I have Rembrandt and Mistral left. Well, the reason I'm thinking it's not Rembrandt is because I think my sister, when she was born, my mom did like baby Mozart. And like baby, and then there were like so many iterations of baby Mozart where it was like baby Rembrandt, baby whatever. And there was nothing spooky about it.
Rembrandt is a musician and not a painter.
No, there was also books. Like it was like baby Mozart to listen to, baby Rembrandt like as a book. I think it's Rembrandt. I'm getting stuck on Rembrandt, so I feel like it probably is Rembrandt. I feel like I'm trying to talk myself out of it being Rembrandt.
Yeah. It's Rembrandt.
Yay!
Trust your gut. Rembrandt is Mercury's second largest crater after Caloris. It's more than 700 kilometers across. It was discovered by Messenger, and it's a younger impact crater based on its shape and the texture of the rim. That's at least what we have decided. And it's only, we think, 3.9 billion years old. The name was approved in 2009.
It's a baby. It's only 4 billion years old.
Baby. Yeah, that's nothing. Which means you'll get the next one right, but let's read it anyway.
Yay!
Born in 1889, this Chilean was a poet and diplomat. They won the Nobel Prize in Literature in 1945, the first Latin American author to do so. Their image is featured on the 5,000 Chilean peso banknote.
Ooh, okay, yeah.
That's Gabriela Mistral.
Love it.
And the Mistral crater is 100 kilometers across, and the name was adopted in 1976.
Wow, I didn't know the one woman on the list.
There were 4 women on the list, technically.
Oh, yeah. That's true. That's true.
But they all had to share one, which isn't fair.
Her Wikipedia image is so, like, giving. She's serving. Like, her hair is, like, perfectly waved. Ooh. I love it.
Nice. Last thoughts about Mercury?
Well, I'm delighted to see that they name the craters after artists. I think that's great, and we haven't really seen that.
Yeah, it is nice.
So I'm excited to campaign for us to be a crater long after we're dead.
Yes. Well, we'll leave it to the fans to campaign for us. But we will leave you a body of work so impressive that you cannot be denied.
Yeah, exactly. It's an easy win. Okay, listeners. Well, wherever you are, I hope you are enjoying your boba, getting a huge straw, and remembering that you are space.
So cute. So delicious.
Yum.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.